What's good, guys? Today we're gonna go ahead and try to find minimum in assorted array. I'm gonna be solving this blind. I know it says solve right here, but I think I solved it like a year ago, so I hella forgot what the answer was. All right, let's go ahead and solve this blind. Okay, let's see. We're given a You are given an array of length n, which was originally sorted in ascending order. It has now been rotated between 1 and n times. For example, the array nums 1, 2, 3, 4, 5, 6 was rotated 4 times. So now it's this, and this is if it was rotated 6 times. Okay. Notice that the array 4 times moves the last 4 elements of the array to the beginning. Rotating it 6 times produces the original array. Assuming all the elements in the rotated array are unique, return the minimum element of the array. So basically, we just have to find the smallest number. We're not given how many times it was rotated. We're just given the list itself. So let's go ahead and try to solve this. Gotta think of an algorithm. I think initially what I'm thinking is like if we see a big number like 6, and then the numbers right next to it, let's check 5 and 1 are a are smaller, if any, or actually, let's see. Oh, damn. Hmm. Damn. It's a pretty difficult one. I think an algorithm, I'm not sure if this is a run roll. We'll run an log n. We grab the beginning and the end, so kind of like a left pointer, a right pointer. And let's see, 1, 2, 3, 4, 5, 6. So we'd get the middle, which is 3. So 0, 1, 2, 3, or 5. You could either take one of these two. Let's just go with 5, for example. Then I'd check the left and the right, compare them to each other. And if the one on the right is actually smaller than the one on the left, then I know the one on the right is actually the answer. So that could work. So get the middle element, compare its left child, or I'm gonna just say its left neighbor with its right neighbor. If the right neighbor is less than the left neighbor, then I know that's the smallest. Hmm, that could work. And if that's not the answer, and let's say if it isn't, uh let's go. Okay, so we got 1 and we got 6. The middle would be 3. Compare this with that. So the left neighbor is actually smaller than the right. So I'd say, where would I search? The left partition or the right partition? I wouldn't know where to search, right? Say to search the left. Check these two. Didn't work. I'll check the left again. Hmm. Oh no. How would I solve this? I have to find the smallest number. Damn. Oh, maybe I could check the ends. So I'll check 3 and I'll check 2. Oh, that might be good. I might be onto something. So you check out left pointer and you check out right pointer. If left pointer is greater than right pointer, then we know we're guaranteed that it's rotated, right? Because it doesn't matter how many times it was rotated. If it was rotated at least once, that left pointer is going to be actually greater than right. So when I look at 5, you got to compare it to the ends, actually. So if I see 5, I know I should move to the right because the numbers are still increasing. You got to find a number which is smaller than this one. Okay. So compare 2, 3, and 2. If the left is bigger than the right. Okay. I think we could go that. So for example, we'll compare 3 with 2. We know that the left pointer is actually greater than the right, so we should check the right partition. So we could do that by increasing this, making this. So we see that the left and the right are still equal, and we reach 1. If our current number is smaller, is 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 smaller than right and greater, or smaller than both left and right, then we know that's the middle. Hmm. Wow, that might be a good algorithm. It might just work on this use case. We kind of have to think of another one to see if it's good. But I think that might be able to work. So 3 and 5. If this number is smaller than both the left and the right pointer, then it could possibly be the answer. Hmm. Hmm. All right, I want to try to run through this scenario again, but I'm gonna try to add a 0 actually. I'm gonna try to run this. Oops. Damn, it's not copying. Let's see. Okay. I want to run through this scenario right here. Oh, it's not letting me zoom in. Okay, I want to run through this scenario, but actually I want to add like a 0 to see if this would change anything. Zero has to be in this position actually. Otherwise it wouldn't be correct. Okay. So we get this, right? So the middle would be 6. Oh my God. So we compare 3 and 2. The left is greater than the right, so we know that this is actually rotated. When we see 6, we know that we want to actually go to a smaller number. So let's go ahead and compute the middle, which would be in this case um okay, we could do 1, and 1 is smaller than both left and right, so we go ahead and have that. Um, I guess we just continue. Yeah, we'll have that. Then two's pointer goes to this. Keep going. Yeah, I think that would work. That would actually work. Okay. I'm just gonna initialize a number called min number. I'm gonna say it's equal to float infinity. So I'm gonna say left pointer is equal to 0. Right pointer is equal to the length of nums. Subtract 1 because we're in 0 indexed in Python. Go ahead and blow my nose. I think I got the algorithm in my head. I'm not sure if it's gonna be the optimal one, but we'll see. Oops. Okay. If left is greater than right, I think we should check if left is greater than right. That should be our first condition. If it's not, then we know it's not rotated. Um, we check if it is even rotated. If nums if left is greater than right for some reason, is greater or how about equal? Would equal work? Okay, well, let's say, can the array just be one? Nums dot length is equal to one. Alright, sure. If it's equal to one, then we just know it's not rotated. Then we can assume it's not rotated. That way we could just do, well, let's run the fucking, it's the regular shit. So, so while left pointer is actually less or than or equal to right pointer. Oh shit. Yeah, if num's left is okay. Yeah, they're just trying to regular binary search then. Okay, let's go ahead and do that. Then we could just say middle is going to be equal to left pointer plus right pointer. And just kind of divide that by two. And then we could say if, oh shit. Oh no, yeah, we could say if middle, actually, min number is equal to minimum of min number, or it could also be nums dot middle. And we kind of just do that, and well, we don't even have to do a binary search because we're not searching for anything. There is no equal target. Wait a minute, that might just be a base case, bro. If this left pointer, oh shit, oh shit, oh shit, oh fuck. Okay, I think I just came something crazy right here. So we compare left and right. We compare left pointer and we compare right pointer. We get the middle, which is 5. So when we see 5, we want to move more to the right. So we actually compute it again, and we get 6 this time. And because left pointer is still greater than right, we want to actually check 1. Okay, actually, let me check this. Okay, so we have 3 and we have 2, right? Left pointer is greater than left right pointer. So we go ahead and check 6. We check 6. Let's do ceiling division actually. So we check 6. 6 is left pointer, 2 is right pointer. Left is still greater than right, so let's go ahead and check 1. Um 2, 6. 6 is the middle one, and then 2 and 1. So left pointer is less than right pointer. Ah shit, we skip over 0 then. Maybe what if we don't do ceiling division? We do regular division. Nah. Nah. What if I go like this? Say 7 actually. Need to run through another use case real quick. Okay, so we have 3 and we have 2. Okay, let's go ahead and compare. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Let's go ahead and compare this. So we have 4 on the right, 4 on the left. Okay, so 6. 6 is gonna be that. So 6 and 2. 6 is greater than 2, so we know we gotta check this other partition. It'd be 0. It's always gonna be the case. What if we rotate it even more? What if this says 3? And then we take this shit out. What if we go like this? All right, so we compare 4, 4 and 3. 3 is 4, okay. That's pretty good. So let's go ahead and check the middle. The middle would be this. So 7's larger than 3. We check 1. Check 1. 1 is less than 3. 1 is less than 3. That hits our condition. No, no, no. Yeah, this is the use case that breaks it. So we compare 4 and 3. Left pointer is greater than right, so we know it's still sorted. Then we actually compare 0. 0 and 3 and 1. Wait a damn minute. Okay, so we got 3, 4, 5. Let's go ahead and check 6. That'll be our middle pointer. So we know that left is still greater than right. Because left is still greater than right, we know that that's not the answer. So let's go ahead and increase it to 7. So our left pointer is now going to hit 6. Wait, hold on. So we got 6. So left pointer is going to be middle pointer plus 1. So 7 compared with 2. Still greater. So 0. Damn, that's fucking crazy. Wait, hold on. I want to just go back actually. Oh, damn. So 1, 2, 3, 4, 5, 6. All right, shit. Let's try this algorithm. Okay, so we check out 5. All right, so now we check these. Left is still greater than right, so left is equal to middle. So middle. Okay, so now middle is equal to 0. So it compares with other shit. Hey, damn. Damn. I want to know more test cases actually. 7, comma 8, comma 9, comma I. There is a fucking giant test case. So compare, okay, so compare this with that. It'd probably be 7. So 7 got 4. 1, 2, 3, 4, 5. So we check 7, right? So 7 is going to be actually 7's gonna be the left pointer is greater than right, so we're gonna try to find the middle of this, which is going to be for 4 division. Let's see, 1, 2, 3, 4, 5, 6. It's gonna be 9. Well, we checked 7. So 1, 2, 3, 4, 5, 6. 6 divided by 2 is 3. So we're gonna check 1, 0, 2, 3. So this. Check this number 9. 9 ain't correct, so we gotta check 0. I think this should work actually. Well, left pointer is less than or equal to, say, right pointer. We go ahead and run this algorithm. First, we compute the middle. Middle is equal to left pointer plus right pointer. And we kind of just do that math. Divided by 2. We like to do floor division, especially for this question. But we should actually have the condition if left pointer is less than, actually, we could check if middle pointer, let's actually call this middle pointer. I'm so locked in. Let's get it. If middle pointer is actually less than right pointer, then we could go ahead less than. Every single number is unique, so we don't have to put equal. We'll put equal. Yeah, I think we put equal actually. I return. We actually gotta put nums. If the number at middle pointer, let's say in this example, where okay, we had this 3 and 2, 7 was it. It wasn't that. Okay, so we have 8 now. 8. The middle one would be this. Yeah. Dude, this is freaking awesome, man. I love binary search. I'm not sure if the solution won't work in this scenario. I might have to use more test cases, but I'm gonna just go ahead and just code this out. I'm excited to see if it works. Okay, so the other condition would be okay. Other condition would be if nums dot middle pointer. We don't care if it's equal actually. Let's say if this is greater than nums. Always moving to the right every time. Nums. Okay, so we just increase it. So left pointer is equal to middle pointer plus 1. I don't think we ever have the case where we have to shrink the right side, do we? Let's see, compare this with that. So left pointer is less than right pointer. Okay, that's true. This is at 0, and that's at whatever the length is. So we get the middle pointer, which is going to be 0. Um, if middle pointer is less than or equal to nums of right pointer. So this is less than right pointer at the current moment. So we just return that number straight up. That would work for this question. Would work for this one. So we compare 3 with 2. So 6. Now we got 3 and 2. We actually get this number right here, 5. 5 is actually greater than 2. So you go ahead and make left pointer equal to middle plus 1. So middle was once 5, so we make plus 1, so 6. We compare 6 with 2, and that middle pointer is 1. And 1 is going to be less than or equal to right pointer, so we just return that. This should work. This should work. Let's go ahead and try to. We don't even need this. We don't even need this shit. Wow. Let's go ahead and test it out. Oh, and we ran into a problem. Okay, let's go ahead and run. Passes this. Let's see if it actually passes everything. Yeah, we only got 2 test cases. I'm trying to see if it was trying to work, but let's see. So we got 4, 5, 7. Let's go ahead and test this out. Let's see how our algorithm actually breaks. Okay, so we compare 4 with 7. That would bring us 5. And left pointer is actually greater. Well, I think we have to actually make the comparison right here sooner. This might just work for one case. Let's go ahead and check it out. If num's left pointer is already less than nums of right pointer, Then we already have the answer. This will run actually really quick. Oh, one, I think. Yeah. So just return nums of left pointer. Let's go ahead and check this. I know we're gonna have at least passed one more extra case. That would work for this one. And looks like I spelled return wrong. Let's go ahead and try it out. 7. Okay, now we got a new test case to think of. Okay, new test case. Go ahead and test out this one. Where does my algorithm break? So we compare 4 with 2, and I think that gets us 7, right? Then we go ahead and check the middle. So left is still greater, so we're going to go ahead and do that. So middle pointer would equal to 0. Mm. Yeah, we should definitely put this condition right here, actually. Oops. I think we should put this condition actually inside our ball condition. Oops. The heck is going on? Oh, shit. Um, damn. Okay, I'll hit Control X, get that shit out of there. Go ahead over here. Okay, but we have to indent this by 1. Okay, looks about right. Yeah, okay. This could go ahead and work. It'll return before reaching this. This should work more. Right, 17 now. Okay. 17 cases worked. Okay, let's go ahead and check out this. New test case. We're always adding new test cases here. Let's go ahead and try to solve it again. Okay, let's see. So we have 5 and we have 4. And 5 is greater than 4, so we go ahead and test 2. Okay, 2 is less than 4, so we know it's good. Wow, but there is this number right here. Hmm. I guess we could see it. We could get the difference actually. Oh my gosh. We know it's how much it's rotated by getting left and right. Yeah, that's crazy. That's that math stuff. So if we go, so 2 and 3, and we could do this number minus that number. So this is rotated 4 times. How do we know if it's rotated 4 times? We could do this number minus this 6 times. No, no. Oh, no. That's only assuming if they count up, right? No, this could be anything. No, no, we can't do subtraction. 1, 2, 3, 4, 5. What? How would I work for this test case? Left is greater than right. Okay, so 2. Okay, damn. Compare 5 and 4. We get 2. We should check two's neighbor on the left. Yeah, okay. Yeah, okay, this is straight up. Hey, what if we put an and nums middle pointer is less than nums of middle pointer. I just subtract by one, right? That could be an out of index error, but maybe not. Let's go ahead and see if this works. I know it's kind of like throwing the shit out. Let's see. Okay, damn. Shooting this shit. Okay. Damn. I might be stumped on this one actually. Damn. I'm gonna have to look for some hints. Did not. Okay. Might not actually be the minimum. Tells you which half is sorted. Okay, I'll use that tip. So let's say if left and right. Oh, we actually decreased the right, huh? Hey, I didn't think of that actually. Okay, so for this, we check 5 and we check 4. Um, oh shit, I think I get it now. We check 5, then we go ahead and check 4. If 5 is greater than 4, then we go ahead and just move our pointer to the right. Say it's, wait, okay. So our middle is going to be 2. Left is greater than 4. Our middle is smaller than 4, so I say middle is this. Oh my god, that makes more sense. Okay, let's see. Let's take off this equal sign. Now we actually have back to the max, or min answer. Just make it back to float of infinity. I get it now. Okay, so left pointer, middle. If middle is less than the right pointer, then we don't actually return this. We just update our answer. We update min answer is equal to min of min answer. Actually, we don't even have to update it, huh? We don't even need min answer. Wait, no, we do. You just say min answer is equal to nums of that middle pointer. I want to try to solve this creatively. I'm not sure if we even need this. If we use the min operation, it'd be better. I think we could do good. Right equals left. Yeah. Yeah, I think this would work. We could update the answer. Then we could kind of just, oops, what's happening over here? Okay, we get that and we kind of compute it. So we know that we could see if we could find even a better answer. So we could do middle pointer is actually equal to, or actually left pointer, or right pointer is equal to middle pointer minus 1. We don't even need this. But we don't even need this part, I mean. Let's go ahead and try to run it through this algorithm. Okay, so we have 5 and we have 4, and the middle would be 2. So if it's less, which it is, then we say right pointer, then this right pointer. So we say min answer, so we could say the potential answer is 2. And now we go ahead and make middle pointer minus 1, so it's equal to 1 and 5. Now we check 5. 5 and 1, and it would be 0. So middle pointer would be 0. I think we just say it's equal to, let's just say right pointer. Yeah, we could update like that, just keep on updating. I think this should work. Kind of creative answer, but let's see. Return min answer. Let's go see if this works. Come on, come on. And we have infinite loop. Okay. I guess we could try to go with the other solutions. Let's just try to, yeah. Let's do minimum of min answer. All right, this should work. And okay, we ran into a problem. Hmm. Yeah, we're not incrementing this correctly. Hmm. Or revert back to the beginning, actually, before I try to get creative with it. You got to try to find a solution first before you get a creative answer. So we compare 5 with 4. Their middle is 2. 2 is less than 4. So mid answer could be potentially 2. But then we go ahead and decrease it. So we do, so now 4 is equal to 1. So we get um, right pointer is at 1. So 1 plus 5, or actually 0 plus 1 divided by 2 would be 5. Middle pointer would be now 5. 5 is greater than that. So middle pointer plus equals 1. So left pointer and right pointer are both at 1. We don't even need this shit. We don't even need this either. I think we could just return. We could just return Num's middle pointer. Am I not doing it correctly? Well, left pointer is greater than right pointer. Right pointer is equal to this. Left pointer is equal to this. Okay, so left pointer is at 5. Right pointer is at 4. Middle pointer is at 2 right here. So middle pointer is equal to left pointer plus right pointer. So that'd be 0 plus 1, 2, 0, 1, 2, 3, 4, 4. 0, 1, 2, 3, 4. So we add them together, divided by 2. So 0, 1, 2. So we're at 2. It's 2. Okay, so if middle 2 is less than nose right pointer, it is. So right pointer is equal to middle pointer minus 1. Okay. Right pointer minus 1, that'd be 1 and 5. Okay. So that finishes. So we go back to middle pointer, right? Then I forgot the EL, the else if. Is that it? What did he exit? Continue. It'd be like this. Dude, this is the keyword, bro. Is it exit? I think I'm missing a keyword right now to say run it back. Like run it back as in recompute this. Yeah, I think I'm missing a keyword. I feel like I am, right? Oh, it's a logic thing. So compare left pointer with right pointer, and we get 2. O2 is potentially the answer. So why even do that? Oh, it's good. It is potentially the answer, right? Okay. So, okay, let's go back. We got 2, and that's less. So we make right pointer 2. So now we get 1 and 1. So 1 is also less than the right pointer. So we make this the middle. So we get 5 and 1. So um, middle is actually, wait, what? Okay, so we start at 2. Middle pointer is less than the right pointer. Okay. So right pointer is equal to middle pointer. Okay, so we still got these two. So middle pointer is now 1. Right pointer is at 2. So middle pointer is greater than right pointer. Okay. So that makes right pointer. So right pointer is equal to middle pointer. Okay, now we got 5 and 1. Middle pointer is going to be 5. So left pointer is equal to middle pointer. Left pointer is equal to middle pointer. Well, middle pointer is left pointer. Doesn't really make sense. Oh, if middle pointer, which is 5, is greater than right pointer. This should be +1, bro. No? I don't even get that logic. They said take this out. I don't get it, bro. What the hell?
Call from unknown.
They said this shit work.
Call from
Comparison now. So I'd be 5. Since it's greater, we go ahead and move that to 6. Just equal to the middle pointer. What the fuck? Oh man. Fuck. Right? That's what I thought. Oh. Yo, what the fuck? Let me just run through this. Okay, so we got 5 and 4. The middle would be 2. 2 is less than, okay, let's see. 2 is less than 4, so we say right pointer is equal to middle pointer. So now we have 2 and 5. So middle pointer is 1. Okay. Now right pointer is 1. So left pointer is middle pointer plus 1. Uh, what if we put equal to? I guess that could work. I don't know what I was going wrong last time. Let's go ahead and try to check that out. I'm gonna go ahead and submit this. I know it's right. I want to see the old version, which I kind of guess I messed up. Yeah, let me see this. This is where I was actually. I thought I was onto something right here. Oh man. Yeah, let me check this shit out. Okay. So, okay, I want to just check this out with this test case. So, middle pointer would actually be left and right. Okay, so we have 5 and 4. We have 2. Okay. I said 2. If 2 is less than that, so middle pointer minus 1. Um, so 5 and 1. So it'd be 1 and 5. 5 and 1. Then we go compute, we get 0. 0 would be 5. So that'd be greater, so middle pointer equals 1. And once they're equal to each other, it'll still run. Mm. Alright, let's see if I took this. Honestly, what's wrong with this logic right here? Okay, so we get this. So we start off at this number right here, 0. So 0. I get it now. We'd be at 5. Okay, so I take this shit out. Okay, so I compare 0. The right pointer equals that. 5. Okay, I don't get this one. Okay, so we're at 0. Middle pointer is at 0, left plus 1. Okay, so left is actually smaller than the right pointer. Yeah, because right pointer is at 3. Right pointer is equal to mid pointer. Okay, so that's 0. Now we're back at 5. So 5 is greater than 0. Num's middle pointer. Hmm. This should actually work. I could turn back right pointer or left pointer. It don't even matter. Yo, see? It didn't make sense. Is this different than the solution they gave me, bro? Hmm. Okay, I think I get it. I fully get this question now. I think I have to put with these equal signs, kind of just really visualize it. Is there any solution? Lower bound? Yeah. I think this is really just some playing around. I think I had the right idea right here. I just kind of, if I took a break and I came back to it, probably would have been able to solve it better. But yeah, that was my first run through solving this question. I try to fully understand it. I think I really get it. If I ever see this question again in the future, let me think. The first thing that would come to mind was probably just comparing the left with the right. Yeah, comparing the left to the right and kind of thinking, what can I do with that information? Then with that, you could go ahead and try to update or increment one of these pointers. I see. I don't think I'll forget how to solve this again. Seems like a pretty good question. I like this one.